Hi friends, in this video we will talk about ACID properties in the relational databases. ACID properties in the relational databases. ACID properties relational databases. Okay, before we will discuss about the ACID properties, first we need to understand what is meant by the transaction. It is really important. What is meant by the transaction? Transaction means unit of work that contains one or more SQL statements like insert, update or delete or select, that can be treated as single action. Okay, this is what transaction. It is really important. It can be treated as a single action. What is meant by the transaction means, in a simple way, it can be termed as a unit of work. Okay, it can be termed as a single action. That action consists of multiple SQL statements. Okay, whether it will be the insert statement, whether it will be the update statement, whether it will be the delete statements, whether it will be the select statement, but all the group of statements denotes a single action. Okay, let's see the example, practical example. Okay, if you are having an app called PhonePay, okay, app called PhonePay. In PhonePay, we are transferring amount. Okay, you are user A, you are transferring amount to user B. Okay, what is the process it involved generally? Okay, first one is check balance of user A. Okay, if balance, for example, you are transferring amount, you are transferring 1000 rupees amount. Okay, if the balance is greater than 1000, it proceed to the further steps. If not, it returns insufficient balance. Right, if the balance is greater than 1000, what happened? Okay, update amount, update balance, update balance in user A and also user B accounts. Okay, this is a process. It is a single action, right? The transferring amount is a single action from user A to user B. Okay. Now what are the queries involved here? For example, we have an accounts table. Okay. First, we need to check the balance. That means, what is the query performed? Select amount from accounts. Okay. Let's assume that user A account number is 1. User B account number is 2. Okay. Select amount from accounts where account number is equal to 1. Select statement involved. Amount is greater than 1000. Okay, this is the next operation, checking. Third, update amount. Okay, set amount is equal to amount minus 1000. Okay, where account number is equal to 1. Okay, next, update amount set amount is equal to amount plus 1000 where account number 2 is equal to 2. Okay, these are the statements involved if you transfer the money from user A to user B. Okay, so transferring the amount is a single action. It will be considered as a one transaction. Okay, it involves these statements, select statement and to update statements, right? All these statements can be considered as a transaction. It can be considered as single transaction. Okay, I hope you people now clearly understand what is meant by the transaction is. Okay, generally in relational databases like MySQL, when the transaction get initiated, we begin transaction okay, statements, okay, then later we made the commit. In this way we initiate a transaction in MySQL, right? Begin transaction means it will understand that it can be treated as a single action. All these statements are you write the statements here, select statement, insert statement or update statement. What are the statements involved here? We can write all these statements here, and finally it will be commit. When the commit got executed, database can understand that the action got completed. One transaction is completed. Okay, this is about the transaction. Okay, now we need to understand about ACID properties. ACID properties. ACID properties. In the ACID properties, A indicates A indicates atomicity. Okay. C indicates consistency. Okay. And I indicates isolation, and D indicates durability. Okay, these are the acid properties. Now we will discuss each and every property in detail with examples. Let's understand. Okay, it is really important for when we maintaining the relational database, understand these properties. Okay, this is also the basic interview question asked for a system design interviews. Okay, it is really important. Let's consider atomicity. What was the atomicity denotes? Atomicity indicates that all queries which are involved in transaction which are involved in transaction must be successful. Even one query is failed, entire transaction will be rollback. This is what atomicity says. Okay, all the queries which are involved in the transaction must be successful. Even one query is failed, entire transaction will be rollback. This property is known as atomicity. Okay, it is really important. For example, if there is no atomicity, what happened? Okay, if there is no atomicity, what happened? Let's see. Okay, if you have an application called PhonePay, okay, developers does let's imagine that there is no atomicity for the PhonePay. Okay, let's take this transaction example, right? The transaction involves what are the operations? Let's recap. First one is a select operation to check the balance. Second one is check the condition. Okay, if balance is greater than the required amount, third one, update operation in user A account, and another update operation in user B account. Okay, let's imagine, okay, it begins a transaction, you are sending the amount. Okay, suddenly your internet connection will drops, otherwise your PhonePay is crashed. Okay, your PhonePay is crashed. What happened? Okay, what happened? What happened? Automatically, even if an amount is cut, okay, amount is also debited from your account, but amount is will not transfer to the another guy account. Okay, what happened? After some time your amount will be back to your account. Okay, if there is no atomicity, your amount will not come back. Okay, let's understand. For example, if you initiate the transaction, you enter the amount and you transferring. Okay, that means what happened? Select statement is completed. Okay, check the condition is evaluated, update operation also completed. But while updating the operation in the user B account, your internet connection is gone. Internet connection is gone. What happened? Your amount got debited, right? Amount is debited here. Amount debited, but not credited. Okay, now what happened? Because your database has an atomicity property, that means even one query in the transaction gets failed, entire transaction will be rolled out. That means what happened? Your update operation is failed. When the update operation gets failed, entire transaction is rolled out. Okay, again your money will back credited to your account. Okay, that is the importance of an atomicity property. Okay, next property is a consistency, but before discussing about the consistency, we will discuss about the isolation first. Okay, later you will understand why I will discuss isolation first. Isolation, it is a most important property. You should understand everything in detail regarding the isolation. Lot of use cases will cover here. Okay, what is meant by the isolation? Isolation indicates that transactions must be independent of each other. Okay, transactions must be independent of each other. Okay, isolation property, remember here, isolation property is like knob. Isolation property is like knob. Okay, developers can use the knob according to their use cases. Okay, how far transactions can able to access the another transactions, it is depends upon the developers. Okay, how much isolation will be required for your application database, it will be completely in the hands of the developer. Okay, let's discuss about what happened if there is isolation is not required, isolation is not there for the database. What are the challenges you faced? First we will discuss about the challenges and also what are the remedies for that. Okay, based upon the levels, developers can choose which level they need for their application. Okay, first, What happened? Isolations are not there. Isolation property is not there. Let's imagine what happened. Okay, first one first one is dirty reads will happen. Second one, non-repeatable reads. Okay, third one, phantom reads. Fourth one, lost updates. Okay, let's discuss everything. Okay, each one is a level. Okay, dirty reads, okay, non-repeatable reads, phantom reads, and lost updates. These are the problems if there is no isolation property. Okay, user can twist the knob. Okay, user can restrict up to without and dirty reads only. Okay, user can restrict up to support to avoid only. Okay, avoid only dirty reads. User can twist the knob up to avoid only dirty reads and non-repeatable reads. User can avoid both the three, dirty reads, non-repeatable reads, phantom reads, only these three. Okay, user can avoid all the four problems also. It is based upon your application. Okay, user can only avoid dirty reads, user can only avoid dirty reads and non-repeatable reads, user can avoid both all dirty reads, non-repeatable reads, and along with that phantom reads also. User can avoid all the four. Okay, all the four. It is based upon your application requirement. Okay, but there is another problem here. Another problem is, if user can avoid only dirty reads, that means it having less latency. Okay, user can avoid dirty reads and non-repeatable reads. It is having more latency than this. Okay, if user can avoid dirty reads, non-repeatable reads, phantom reads, having more latency than these two. Okay, if user can avoid all the four problems, then we have more latency. Okay, less latency, this is having more latency. This is level 1, level 2, level 3 of isolation. This is level 4 isolation. Okay, based upon the user's requirement, developer can decide which level of isolation will be required. Okay, if there is a level 4, you avoid all the isolations, but you are having a more latency. If you are using the level 1 isolation where only avoid the dirty reads, we have the less latency. It depends upon the developer's choice. Okay, before understanding all these things, let's understand all these four problems very clearly so that you can easily decide based upon your application use case which level of isolation will be the required. Okay, see here. First one is dirty reads. Okay, dirty reads. Generally, we already discussed what is a transaction syntax. We will begin the transaction. Okay, later statements execution, statements execution, later commit the statements. Okay, this is a flow of the transaction generally. Okay, generally, let's example to understand about the dirty rates. Let's understand the example very clearly. We have two transactions. Okay, first transaction 1 always reads the balance. Okay, second transaction 2, okay, updates the balance. Okay, this is what two transactions would do. Okay, updates means some credit or debit will be happen. Okay, credit or debit will happen. Here always reads the balance means checking the balance, transaction 1. Okay, dirty reads means definition, your database able to read uncommitted transactions. Okay, this is what dirty rates will indicates. Example, we have two transactions. Transaction 1 always reads a balance. Transaction 2 updates the balance. Let's see. This is transaction 1, transaction 2. Okay, first we have the balance. Account balance is 3,000 rupees. Okay, your account balance is 3,000 rupees. What happened at the time of T1? Okay, transaction 1 reads the balance. What it shows? 3,000 rupees. Okay, it reads the balance. Okay, still this transaction is not yet committed. Okay, at the time of T2, what will be happen? This transaction to debit the balance. Okay, debit the balance. What happened? It gets debit the balance. What will be happen? Okay, debit the balance. Then the balance will be 2,000. Again at time T3. Okay, when the transaction checks the balance, it denotes 2,000. Okay, while committing this transaction 2, okay, while committing the transaction 2, while commit the transaction 2, there is a problem. There is a problem. Again at time T4, again this transaction checks the balance. Because this is not yet committed, again it is showing us 3,000. What happened here? Initially it is shows the 3,000 rupees balance. Now it is in middle, it was showing the 2,000 rupees balance. In 3,000 rupees balance again it shows. What happened? There is a ambiguity here. right? Let's understand these things. For example, there are two users, one PhonePay account, there is a wife and husband, one PhonePay account. Okay, husband is doing the transaction once, that means checks the balance. Transaction to wife's always spends the balance. Let's take an example. Okay, spends the balance, spends the account. When the husband checks at the time of T1, that means at 12 o'clock, okay, it shows the balance as 3000. Okay, now at the time of 12:05, wife debit the balance to purchase something. Okay, 1000 rupees is debited, but some again at 12:06, when husband checks the balance, it shows 2000. Okay, it shows 2000. Still this transaction is just debited, it is not yet committed. Okay, your transaction is just only the debit operation, that means one update operation will be completed, but other update operation is not yet completed. Okay, that means for the others it is not get credited, for the shopkeeper account it is not yet credited, but at time of T3 when you checks the balance it shows 2000 because there is no isolation for the dirty rates. That means your database is able to read the other transactions which are not yet committed. That's why it is showing the balance as 2000 rupees. Okay, once we are trying to credit the account balance to the shopkeeper, there is an internet issue and the transaction is not yet committed. Okay, again this husband checks the balance at 12:07, again it shows 3000. Okay, is it acceptable? It is not yet accepted, right? It should always maintains proper balance. When the transaction is committed, then only the balance should be shown as debited, right? Without the transaction is not yet committed, it shows a 2000 and later gets a 3000. Then what will be happen? It is creates an ambiguity. Okay, it creates an ambiguity. So this is an drawback for the dirty reads. When your database is able to read the uncommitted transactions, this becomes an huge problem. Okay, this is in dirty reads. Now what we need to do to avoid the dirty reads? What we need to do? That means what we need to do is transaction should able to read committed transactions only. Okay, transaction should able to read the committed transactions only. This is only the solution. Okay, to read the committed transactions, you need to put the isolation property as read committed. This is the isolation property at level 1. This is an level 1 isolation. If you configure your database property isolation property as read committed, then your database will able to read only the committed transactions, so that you can avoid these dirty reads. Okay, now second problem is non-repeatable reads. non-repeatable reads. Okay, non-repeatable reads. What is the non-repeatable reads? Say, okay, your transaction now able to read the committed transactions, but still there is a problem will appear. Okay, let's see the example. There are two users, again husband and wife. Okay, both are using same PhonePay account, same account. Okay, same account through their PhonePay. Through their PhonePay. Okay, now see what happened. Husband, okay, and wife. Okay, now at time t1, okay, again, okay, here use case is both are doing transactions. Okay, that means here use case is both are doing transactions. That means both are paying amount to someone at time t1. At time t1, that means 12 o'clock, for example. Okay, first when we husband transferring, there is an account balance called 1200. Okay, 1200, there is a balance. Okay, 1200, there is a balance. In the account, 1200 rupees balance. Your husband trying to debit the 1100 rupees and wife trying to debit the 300 rupees. Both are in two different places. It's okay, wife is at home and husband is at some other place. Let's imagine. Okay, husband is trying to debit the 1100 rupees from his account because there is a 1200 balance. In the same way, wife is also start debiting 300 rupees with 1200 rupees balance. Okay, it's quite natural, right? Both are unaware of each other while doing the transactions because the both are at different places. Okay, at 12 o'clock, husband trying to debit. What happened at the 12 o'clock? It checks the balance. Okay, at it gives 1200 rupees. Okay, at time t2, 12:01, wife checks the balance. Check the balance. How much it shows? It also shows 1200 rupees. Okay, satisfied. Because wife is at home, her internet connection is so fast. Okay, what happened? Let's imagine her internet connection is so fast. That means at transaction 3 at 12:01 in some milliseconds, like 12 milliseconds, it's update balance. Update the balances. Okay, both debit and credit. Okay, credit to some shopkeeper also. Okay, now the balance, what happened? Now the balance exists in the account is 900 only. Okay, 900 only. At time T4 at 12:01:59 milliseconds, transactions committed. Transaction is also successfully committed. Okay, now at because husband is an outside, his transaction is little bit slow because his internet connection is slow. At time T5, okay, at time T5, that means 12:02, okay, it is trying to update the balance. What happened? Okay, update the balance as 1100 you need to debit. What will happen? It goes into the negative balance. Because his internet connection is low. So that means it takes 2 minutes to fetch the balance 1200. Okay, in the meanwhile wife transaction is committed already. What happened? Okay, what happened? It goes to the negative balance. At the time of a transaction T1, it checks the balance, it's satisfied, right? 1200 is always greater than 1100. When he is going to the update the balance, it takes 2 minutes time. It's quite natural because here outside his internet connection is a little bit low. In the meanwhile, wife is at home. He did the transaction of 300, right? So what will happen here? It goes to the negative balance. It goes to the negative balance. This is absolutely wrong, right? Which is absolutely wrong. That means this is a problem of this problem is called non-repeatable read. This problem is called non-repeatable read. Not okay. This is one of the example. Let's see the another example here. Similar example for a non-repeatable read. For example, if you take the practical example as BookMyShow. Okay, there is one ticket of famous movie. Okay, there is a one ticket of famous movie. Same case appear here, right? There is a user one, which is internet connection is slow. Okay, there is user 2 with fast internet. Okay, your database doesn't have a capability to isolate the non-repeatable reads. What happened? Same, there is one seat, right? There is one ticket. On same ticket for booking, this user one also tries for also same ticket, and this user 2 is also tries to the ticket. When check the both are initiated a transaction. When checking the balance, user 1 little bit travels slow, but user 2 already booked and committed. What happened for the user 1? Ticket is not yet booked. Ticket is not yet booked. It goes into the negative. Ticket will not book. But beginning of transaction it showed as ticket is available. Which is a bad experience for the user, right? he cannot understand what is happening. Not the huge traffic here. Huge traffic, it may be occur, there is a chances. It is not huge traffic. Okay, there is a one single ticket in the hall, two users. For example, there are many tickets, there are 100 tickets, but one ticket both the users are trying at the same time. One user at the fast internet, one user at the slow internet. For one user it gets booked, for other user it goes into the negative. He cannot understand what is happening, because by when he begins a transaction it is showing as empty, but still the book ticket is not yet booked. It is not fast selling movie, it is a slow selling movie. But the problem is both the users selected the same seat. It's quite natural, which is not accepted, right? In the case of these kind of applications, BookMyShows, which is not yet accepted. Even the banking application PhonePay, this case is not yet accepted for PhonePay. Okay, how to avoid this case? Here transaction is committed. That committed transaction only shows. We're updating the balance, it is not yet. Balance is insufficient, it is abrupted, right? So to avoid this non-repeatable reads, there is isolation property called repeatable read. Okay, if your database, it is level 2 isolation. If your database is configured the isolation with repeatable read, it can isolate dirty reads as well as non-repeatable reads problem. Both the issues are solved. Okay, this is one level using the repeatable read. Another solution is we can solve at the code level also. Okay, what this repeatable read do? Repeatable read perform pessimistic lock on the rows, okay, on the particular rows where the transaction is depends on. Okay, this is one solution. Okay, when the transaction is performing, it performs a lock on the rows, particular rows, so that another transaction wait until this transaction will performed on that particular rows itself. Okay, that's what the repeatable read will do. Okay, another solution is we can solve at code level also. How we can solve at the code level? By using versioning. How it will be? Okay, let's see. When both the users check the balance, it will give us the balance 1200 for husband. Along with the balance, it is gives a version number also. That means version 7. Okay. At the same time, for the wife also, it will give a 1200 with version number 7. Okay. When the wife performs 300 debited, okay, it update the statement like this. Okay, update account where sorry set amount is equal to amount minus 1, sorry, amount minus 300, where account number of purchaser account number and version is equal to 7. Okay, now version is already 7, it gets updated. Now 300 rupees debited, and again update account set amount, okay, amount plus 300, where account number is equal to, sorry, confused here, this is not a purchaser account number, it is an wife or husband account number. Okay, purchaser account number. Here no need of checking the version, it goes for 300. Okay, now what will completed? Transaction got completed when husband, okay, here committed this transaction because of his internet connection low. Now it start update, again update account, okay, set amount is equal to amount minus 1100, where account number of wife or husband account number and version is equal to 7. Okay, when the amount got detected, here there is a version update. Okay, when the amount got detected, here there is a version is updated as a 8. That is a versioning beauty. Okay, when we use a version, when we perform this update statement with the wife, it updated as a version 8. Okay, now set amount is 1100 and version is equal to 7, it is gets failed. When the failure happened, what happened? Again it retries the transaction. It retries the transaction. When they retry the transaction, now again checks the balance. Checks the balance. When it checks the balance, how much amount it will comes? 900 with version 8. Okay. Now user request is 1100. This is a user request. Now husband will thrown an error, insufficient balance. This is how versioning will work at code level. This is at code level, not at database level. Even some databases using pessimistic logs, some databases using versioning of their own. It is their choice, but I'm saying these are these two solutions, whether locking the rows or maintaining the versions. Most of the applications we is configured the isolation as a property. That means isolation as a repeatable read property, and also in the at code level they are taking care with the versioning also in most of an applications. Okay. Another next isolation property is phantom reads. Phantom reads. Okay, phantom reads. Before understanding the phantom reads, let's understand with an example. Let's understand with an example. If you take an application like Big Basket or some whatever it may be, Instamart as an examples here. Okay, they had an inventory management. Okay, that means stocks. There is a stock table. Okay, there is a product. Okay, quantity, and stock. Right, product, quantity, and stock. For product 1, quantity is 10 quantity. Okay, sorry, this is not a stock, this is price. Okay, price for each is 2 rupees each. Okay, there is a product 2, quantity 20, price for each is 3 rupees. Right, there is a stock table. This is a product ID. 1 and 2 are the product IDs. Okay, they are maintaining like this. Okay, in their account section. This is about account section of their Big Basket or something. Okay, Big Basket or Instamart. Transaction 1, what happened? In the transaction 1, they perform the query like this: select product into multiplication. Right, sorry, not product, I was confused. Select product ID, comma, quantity into price. Price from stock. Okay, this is the first query in the transaction. What it gives? It gives product 1, quantity and price. What is the quantity and price? 10 into 2, it is giving the 20. Okay, and product 2, it gives 20 into 3 as 60. Right, this is a table it comes. Right, next, second query. Select sum of, within the same transaction, okay, quantity into price from stock. That means what it gives generally? 80. This is an output. Right, generally. Let's take transaction 2. Transaction 2. What is a transaction 2? Insert statement. Insert. Okay, insert into stocks into stocks. Okay, product ID, quantity, price, values as product ID 3, quantity is 5, and price also 4. Okay, this is a transaction 2. Okay, now the table becomes what? Product ID, quantity, price. Product ID 1, quantity 10. What is the price we give it? 2 rupees kada. 2 rupees, right? Okay. Product ID 2, what is the quantity we gave here? 20. Price is 3 rupees. Now the product ID is 3 and quantity is 5 and price is a 4 rupees. This is a new row which is added. Right? Let's see. These are the two transactions. Okay, these are the true transactions. Let's imagine this is transaction 1, right? This is transaction 2. Okay, at time t1 at 12 o'clock, okay, the first select statement will execute it. That means the product ID, quantity, price from stocks. It gives us output as 1 to 20 and gives us 60. Okay, at time 2 t2, some 12:00:02 milliseconds, from transaction 2 there is an update. Okay, there is an update. That means transaction 2 will be happen. That means there is an insert of the databases will be happen. That means what is the output here? 1, 2, 3 in the table. 10, 20, 5, 2, 3, 4. Okay, this is a transaction 2. At time t3, that is 12:00:03 seconds, 3 milliseconds, this statement is happened. Select some quantity into price from stock. What it gives? It gives 100. Right? Because we have in the table there is updated, this is 20, this is 60 and this is 40. Total it gives 100. This 100 will be shown in the transaction 3. There is ambiguity, right? For transaction 1, for the first statement, it is gives a listing as only 2 items, and transaction 3 it gives a total amount is 100. This transaction 2 is committed immediately. Committed at T2 itself. What happened here? Why? There is a problem with insertion. It is not a non-repeatable read problem. It is a phantom read problem, because here not update, insert statement will be happened. Okay, here there is no chance of pessimistic lock, or maintaining the version, because it is because it is new entry. What we have to do? It is absolutely wrong, right? In the listing we had showing the 2 rows, but in the total it gives an 100. It is an ambiguity for the user. To solve this problem, the isolation level is serializable. What the serializable will do? Serializable allows transactions sequentially. It is level 3 and level 4 isolation. Generally, if you maintain the isolation serializable, it gives a more latency. Generally, in the production, we are handle at code level. Okay, we will make transactions sequentially at code level itself, because if you put the isolation serializable at database level, it gives a more latency. Generally, in practical, it is depends upon application. Some applications, even there is a latency, there is no issue at all. Even the banking, in the case of the banking sector applications, latency is always and less priority. Okay, perfectness or consistency is a high priority for the banking application. So in that cases, maybe you can put an isolation in serializable. It doesn't have a problem at all. Okay, based upon applications. Some applications, they are okay at maintaining an isolation level at database level. They are handled at the code level. Okay, because it gives an more latency. It is for level 3 and level 4 isolation also. Okay, there is another problem, is another issue without the isolation is loss of data. For the loss of data also, isolation technique is serializable. Okay, it will solve all the isolation levels. Serializable. Okay, let's see the loss of data. What the loss of data will be happen, how, in which case the loss of data will be happen. Okay, same example, PhonePay. Let us consider PhonePay application. There is one account. Okay, husband and wife are using. Okay, now both are trying to credit the balance into the account. Okay, both are trying to credit the balance into the account. Let's see. This is transaction 1, husband. Okay, transaction 2, this is wives. Okay, time t1, for example at 12 o'clock, it checks the balance. Okay, at time t2, 12 2 milliseconds, transaction 2 checks the balance. Okay, at time t3, at 12:00 at 10 milliseconds. Okay, 100 plus 20. For example, initial balance, consider the initial balance is 100 rupees. They are depositing 20 rupees. What happened? 120. Okay, generally. At time t4, that means 12:00 for 12 seconds, adds the balance 100 plus 30. Okay, this 120 is not yet committed, but here it is not able to see, right? 100 plus 30, 130. Okay, here the balance is, final balance is 130. At time t5, what happened? At 12:00 for 14 seconds, it is got committed. Okay, at time t6, 12:00 at 16 seconds, 16 milliseconds, it is committed. Now what the account balance generally? He deposits, husband deposits 20 rupees and wife deposits 30 rupees. So initial balance is 100. General balance, actual balance is 150, but here only 130 it shows. This is called the loss of data. Okay, at the same time, for this one also, solution isolation level is serializable. Or you can handle at a code level. You can handle the transaction 1 first, completely husband, later you can handle the transaction 2, wives. Okay, these are the isolation levels. Let's recap the isolation levels. Isolation levels are dirty reads, okay, non-repeatable reads, phantom reads, loss updates. Solutions for this is dirty reads, read committed, okay, repeatable read, serializable. These are the isolation levels. Let's draw the table. Okay, for dirty reads, if you use a read committed, there is no dirty reads. If user read committed, there is no dirty reads, but there is non-repeated reads, there is a phantom reads, there is a loss updates. If user the repeated read, there is no dirty reads, there is no non-repeatable reads, but we have phantom reads, we have loss updates. If you use the serializable, we don't have all these things. Okay, this is about the isolation. Now we will discuss about consistency. There are two types of consistency. First one is consistency at data level. Second one is consistency at reads. Okay, there are two types of consistency here we need to discuss. First, what is meant by the consistency at data level? If database changes state when transaction is completed, it should follow the rules. It should follow the rules. So if the database is consistent, that means definitely it should have atomicity, it should have isolation. Along with that, it should follow the rules like foreign key. Okay, foreign keys and primary keys. Okay, all these three combination will gives you the consistency at data level. Okay, let's see the example. Same, the inventory management. We have stocks table. Okay, this time item. Okay, ID and total. Okay, we have soaps. Item ID is 1, total is 5. We have washing liquids. Okay, item is 2, we have stocks as 3. Let's consider this is 5. Okay, now we have another table called inventory. Okay, inventory, we have an ID, brand, stock ID and total, right? And total. We have ID 1, brand ID is Lux soap, stock ID is 1, total is 3. Okay, and we have ID 2, and let's take it is Rexona soap. Okay, it is stock ID 1, total 2. Third, it is under in liquid, okay, and stock ID is 2 and total is 2. And for surf excel, the stock ID is 2 and total is 1. Okay, what is meant by the consistency? There is a relationship between this ID to this stock ID, right? This is a relationship. There is a foreign key relationship between this ID to this stock ID. For example, there is an ID of 1. This is ID of 1. There is a total 5 quantities. Okay, now this ID of 1, what 3 plus 2, how much? 5 quantities will be there. 5 quantities will be there. At the same time, we have the ID 2. We have the washing liquids total is 3. If you check this with ID 2, we have the total 3. Okay, this is called the consistency in data. Even one transaction is completed, okay, even one transaction is completed, if there is a change will be happen, state change will be happen, that means the values gets changed, it should follows the foreign key relationships, okay, then only there is a consistency in the data level. So to achieve the consistency at the data level, definitely the database should have atomicity property, definitely it should have the isolation level, proper isolation level according to the application. Okay, at the same time we have the foreign keys and primary keys, then only there is a consistency at the data level. Okay, now consistency at read level. Consistency at read level. What the consistency at read level will says? Consistency at read level will says that, I think we already aware of this cap theorem. If not, please check my previous videos, it will have. Okay, cap theorem, what is the C in the consistency? C means consistency, right? What the cap theorem denotes? Cap theorem will satisfy out of the 3 properties, only 2 properties it will have strictly. So for a distributed systems, generally we have partition tolerance. That means whether we have the consistency, whether we have the availability, there is a challenge. That means whether we have AP systems, whether we have CP systems. Okay, in the case of the AP systems, there is an eventual consistency. In the case of the CP systems, strict consistency. Okay, even we have the relational databases like MySQL at cluster level. Cluster level is a strict consistency, and MySQL at master slave architecture, it is eventual consistency. Okay, what are the AP system, what is the CP systems, what is a cap theorem? I already made a complete video on that. You can have a clear-cut understanding if you refer that video. Okay, this is a consistency at read level. If you having a strict consistency, you can, if you perform a write request, if you perform a read request immediately, the whatever the data you previously written, that data will come. If you have a strict consistency, eventually consistency means it will reflect a little bit of late. Okay, this is what about the eventual consistency. This is about the strict consistency. This is about the consistency at read level. Okay. Now we will talk about durability. What the durability will say is, once transaction is committed, even database crashes, it will sustain or persist. This is what about durability. Okay, if you take an in-memory databases, for example, in-memory databases, if we restart, all data is gone. Okay, it is not durable. Okay, once transaction is committed, even if you restart the database, even your entire infrastructure got crashes, and later if you keep a new infrastructure, still it is persist. It cannot revert back. That property is known as durability. Okay, I think we have clearly understand about what is a transaction, starting from the transaction, atomicity, isolation and isolation levels, and consistency and durability with clear-cut proper practical examples. Okay, if you like this video, please share and subscribe this channel. Thank you so much. That's it for today. It's a long video, but it is really worth, because ACID properties is a basics for the RDBMS interviews.